Evening, everybody. So, tonight we are going to be talking about graphing exponential functions. And when we graph exponential functions, there's going to be some stuff to go with that. Now, we've already done a little bit of this already. So we're just going to be doing a little bit of review as well as trying to pick up some new stuff, and we're going to be working with these over the next couple days. All right, so recommendation, anytime you want to graph exponential functions is, and actually, let me undo that. All right, exponential functions, there's two different types. You have exponential growth and you have exponential decay. Growth means as you go left to right, so as I go this way, my function is going to be increasing, and that's not what I wanted. My function will be increasing like this. Decay is the exact opposite. As I go left to right, it's going to be going down. Okay? When I do these, I'm going to go ahead and start by doing an XY table. And I'm just going to pick values for X. Now, I can pick any value I want, really. But let's go ahead and I'm going to pick -2, -1, 0, 1, and 2. And this is what we call the parent function. So all of our functions will be translations off from this. So it'll be this function. It may get squished, it may get stretched, it may get moved left or right or up and down as well. So now I'm going to plug these in. So if I do y equals 2 to the -2nd power, okay, 2 to the -2nd is going to be 1/4. Okay, how you do that is you take this part right here, you move it to the denominator, which means it becomes 1/2 to the +2nd power. 2 squared is 4. So this is 1/4. Then you have y equals 2 to the -1st, which is the same thing as y 1/2. Anything raised to the 0 power is always 1. 2 to the 1st is 2. 2 to the 2nd is 4. And let's go ahead and do one more here. 3. And I'm actually going to do -3 as well. 2 to the -3rd is 1/2 to the 3rd, which is 1/8. And 2 to the 3rd is 8. Alright, so let's go ahead, and you can see that my negatives, these numbers are small and they're getting smaller. So we went from 1/2 to 1/4 to 1/8. Okay, so I don't need to have a large negative area for the y's, because actually I'm not ever negative right now. Okay, so I'm going to put my x-axis down here. And I'm also going to put my y-axis closer to the left as well. Okay? And for these, I'm just going to go up by ones for right now. So we have 0, 1, which is right here. Okay? We have -1 and 1/2, which is going to be right there. You got -2 and 1/4, which is down a little bit more. You got -3 and 1/8, which is down there. All right, and then you have 1 and 2, 2 and 4, and 3 and 8. That's 4, 5, 6, 7, 8. And this is actually going to continue. And as you're going, you should be able to recognize that this is just going to continue going up. All right. Now, this one here, very carefully, I know it's hard to actually see it by the graph, but if I put in -100, it's going to give me a number that's still greater than 0. Okay? So these functions don't ever actually, or this function will never actually touch 0. It'll get really close, but it'll never touch it. Okay? So now when we go to this one, we'll do our XY table again. And let's do -3, -2, -1, 0, 1, 2, 3. All right. So now you're going to be doing y equals 1/2 to the -3rd power, which is the same thing as 1 over 2 to the negative third, which gives you 2 to the third, which is 8. And as you do these, you can use a calculator. So if I do negative second, it's going to give me 4. This is going to give me 2, not 0. This will be 1. This will end up being 1/2, 1/4, and 1/8. Okay? So now, this time, I'm going to put my y-axis closer to the right, and I'm going to put my x-axis still closer to the bottom. And now let's go ahead and graph this function. All right, so you've got 3 and 1/8. This one is 1/4, 1/2. Okay, you got 0 and 1. You got 1 and 2, 2 and 4, 3 and 8. Right there. Okay. So, this is what we call a exponential decay function. How you determine if it's decay or growth is this. The number that's being raised to the x power, so this number here, the base, if this is a fraction, the function will be decreasing. If this was a, for example, in the previous one, this was a whole number, not a fraction, so this was a growth function. This one was a decay function. Okay? So let's go ahead and let's check out one more now. Okay? So, I want you to see, this is y equals 2x. We did negative 3, negative 2, negative 1, 0, 1, 2, 3. This was not 8. This is 1/8, 1/4, 1/2, 1, 2, 4, 8. Okay? I want you to see the correlation here. Alright? So, for this function, it's still 2 to the x, so we're going to do negative 3, negative 2, negative 1, 0, 1, 2, 3. We're going to use the same 7 numbers for x. Now we're going to plug it in for y. So you get y equals 2 times 2 to the negative third power. Well, we know 2 to the negative third is 1/8. Now 2 times 1/8 is going to be 2 over 8, which is 1 over 4. This is 1/4. Okay, we do it again. This was 2 times 1/4, which is 2 over 4, which is 1/2. Now you should be noticing a common theme here. Here it was 1/8. Here it was 1/4. We know that 1/4 times 2, 1/8 times 2 is 1/4. So let's try it. 1/2 times 2 is 1. So let's put a 1 there and let's see if it works. So what I did was I took this one and I multiplied it by 2 and I got 1. So let's see if it works. Y equals, you got 2 times 2 to the negative first. This is 2 times, this is 1/2. That's 2 over 2, which is 1. So it works. So we should be able to just take each one of the y values and multiply it by this 2 right here to get our new y values. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So these are our new y values now. So let's go ahead and again, we have no negative y values, so I'm going to keep this low, close to the bottom of the graph. The x values now, they're going to be the same. I'm still going to go ahead and move it a little bit closer to the left side. And now let's go ahead and graph. So you had negative 3 and 1/4. You had negative 2 and 1/2. You had negative 1 and 1. Now you had 0 and 2, 1 and 4, 2 and 8, 3 and 16. So it's 8, 9, 10, 11, 12, 13, 14, 15, 16. And again, this is going to get really close to 0, but it's not quite going to reach it. So if we look at this graph compared to this graph, you notice that this graph goes up fast, all right? But it doesn't go up quite as fast as this one because our other one came out, just roughly here, our other one came out the other one kind of comes out like this. Okay, now it's not an exact replica of this, but it's somewhat close. So you can see that this one increases slower than this one. Okay, so this is also what we call exponential growth. All right, make sure you guys write down your steps or an explanation or a summary. I also want you to write down any questions you may have, and I will be checking this stuff tomorrow when you come into class. Have a great night, and I will catch you guys later.